So here's this problem. You've got a 4-liter balloon at a pressure of 50 kPa. It was changed to 6 liters with a pressure of 85 kPa and a temperature of 75 Celsius. What was the initial temperature? So now you want to pause the video for 5 minutes and give yourself a chance to solve this problem.
Yeah. Okay, let me quick.
And then you can unpause it and see the answer. So first thing you're going to do is write down all of the info. We know that we've got a V1 of 4 liters. We've got a P1 of 50 kPa. We've got a T1, which we are trying to find. We've got a V2 of 6 liters. We've got a P2 of 85 kPa. And we've got a T2 of 75 Celsius. And anytime you're given a temperature, go right away and convert it to Kelvin. So that means add 273. So don't even wait, just go ahead and add the 273. Which comes out to be 348 Kelvin. Yep, so based on the information that we know, there's only one equation that's going to work, and that's the combined gas law. So write down your combined gas law. And now you got to do the algebra.
Dun, dun, dun.
So in order to get T1 by itself, I'm going to first multiply both sides by T1 to cancel out the T1s. So that gives me P1 V1, P2 V2, T1 over T2. Then I'm going to multiply both sides by T2, get rid of my T2, and that gives me T2 P1 V1 is P2 V2 over T1.
Wouldn't it just be easier if you did you just plug the numbers in and then cross multiply?
Well, you need to know how to do algebra.
What if you do know how to do algebra?
And the way you typically do problems in science is you start with the generalized equation, do the algebra, then you plug it in. And you actually will make less mistakes if you get used to doing that. Last step, divide by P2 V2. And now we have T2 P1 V1 over P2 V2 is equal to T1. Now that you've done the algebra correctly, and if you're going to go on in science, you need to be able to do algebra, minimum. Eventually you're going to have to do calculus. But at this point, you know, if you're considering going on in a career in science, you've got to do algebra. There's no way around it. Yep, Julia. Yes. I'm going to do that one next.
When would you use chemistry, like as a doctor?
As a doctor?
Yeah.
So most of the chemistry you use is biochemistry in drug interaction and how they act with the body, and also diagnosing. Like when you take vital signs, one of the things they ask is like bicarbonate levels, and you know how to write the formula for bicarbonate. Also knowing like what is the acidity in the blood, knowing how many dissolved gases are in your blood, because if your dissolved gases aren't at the correct levels, it means you're not getting oxygen efficiently in and out of the body. But like as far as moles, doctors don't really need to use moles.
Yeah.
What other stuff they do?
My brother's wife, she's a nurse. She says the only math she has to do is like when she subtracts numbers from liters.
But I'll say this: about, like, if you're going into nursing or pharmacy, you do need to know the metric system. Because if there's a mistake and you don't catch it, that person dies.
Oh, gosh.
So, like, my friend was a pharmacist, and they put on there that taking the directions were to take 10 grams a day. It was supposed to be 10 milligrams. I mean, that would have been 1,000 times the dosage. So, but she caught it because she knew the metric system.
I feel like everyone knows the metric system now.
All right, let's plug in the numbers.
Saving lives.
Saving lives.
Not all heroes that wear capes.
I hate red.
So this is going to equal our T1.
Mistake. You wrote
He dropped the marker.
He dropped the beam.
And I get T1 is 136. And of course, we need units.
He dropped the beam.
KPA cancels with KPA, liters with liters. The only unit left is Kelvin. So 136 Kelvin.
Calvin Klein.
Yep, Mira.
Oh!
And I made the same mistake earlier.
Put it up there.
2 sig figs.
You heard that YouTube channel. He made a mistake. Wow. This is Casey talking. Casey Keys. Ooh, I got you. I don't care. People can come to my house.
All right, so
Throw a party.
the one thing that, so this is one way of doing the algebra. But I'm going to show you another way to do it. And it's faster.
Should we call this extra credit? If we're putting it down in our extra credit? Like, doesn't sound like brain teaser. What is it?
Here's 5 points, right?
5 points if you got the problem right. Anytime you have a fraction, the fastest way to get one of your variables into the numerator is just take your fraction and flip it. It'll still be valid. Anytime you're wondering if something is valid, plug in numbers. If I flip both of these, is that expression still true? Yeah.
Yeah.
So then that must be valid mathematically. So the fastest way to solve for T1 is to flip it.
I just crossed multiply. That's even faster.
And then all I have to do is multiply both sides by P1, V1. So that is another way you can solve for T1 and you'll get the same answer.
Wait, so why can't you just cross multiply?
You can cross multiply too.
Oh, okay. I thought you did once.
No, you can. There are more than one way to do this. But I'm just saying you should do the algebra first before you plug in your numbers. Okay?